Good evening to one and all. Now today we shall discuss the next important result which we have to prove in this today's lecture. The most important result which we have to prove, and that is D'Alembert's principle. See this, you know that in the last but one lecture we have studied the degree of freedom. Now we want to, how many students are here in the online lecture? Now you tell me the formula for the degree of freedom. First of all, I want to check how many students are on the online lecture. That is Sujata, Arti Patil, Archana Suryavanshi. Now you tell me the formula for the degree of freedom. So today in this live lecture, we have to discuss the D'Alembert's principle. Now, before starting the D'Alembert's principle, already we have seen the concept of a holonomic and non-holonomic system. Also, we have seen the definition of the Scleronomic and Rheonomic system. Also, we have discussed the examples based on this. आवाज येतो का रे? व्यवस्थित आवाज येतो ना स्टुडंट? हा, आवाज मध्ये काय? Do you hear me, students? Are you hear me? Now see this. Actually, the degree of freedom which we have studied, generalized coordinate, we shall discuss now, because yesterday due to the some sound problem, due to some hearing problem or mic problem, you are not able to hear clearly, so I shall revise yesterday's some part here. What is meant by the generalized coordinates here? The position of a system of a particle is determined the value of number of independent variables which is equal to the number of degree of freedom. You know the degree of freedom, formula for the degree of freedom is 3n minus k. Then its independent coordinate are called as a generalized coordinate. Let r1 comma r2 dot ri be the coordinates of a particle of a system where I is equals to 1, 2, 3 dot n, means these are the particles. In this case, the independent variables are q1, q2, q3 dot q3n minus k. See this is the formula for the degree of freedom, and in that degree of freedom, n means the particles, number of particles. Okay. Then the position of a particle in the form of variables we can write in such a way that here, see this. Thus, by using these variables, by using these coordinates, we can write the position of the particle in the form of a coordinate such as r1 bar is equals to r1 of q1 comma q2 dot qn q3n minus k comma t. T means at the instant of a time we have measured the position of that particle. So t gives a time, instant of a time. Okay. Now second we shall write r2 bar is equals to r2 bar of q1 comma q2 comma q3 dot q3n minus k into t. So Rn bar is equals to Rn bar of q1 comma q2 comma q3 dot 3n minus k. So these equations are known as the parametric representation of the variable Ri. See this. Now the generalized velocity. Next we shall discuss the concept of generalized velocity. Consider the system of n generalized coordinates with independent variables q1 comma q2 dot 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 qn. Then the position of a particle using these variables is given by r bar is equals to r bar of q1 comma q2 comma q3 dot 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 qn. Suppose this is equation number 1. Now you know that. चलो रे स्टूडेंट्स, वेलोसिटी का फॉर्मूला क्या है? दिस इज अ सपोज डिस्प्लेसमेंट. r bar means the position vector, or it is also known as a displacement vector. Now we have to find out the velocity. R bar is a displacement vector. We have to find out the velocity. Can you tell me what is the formula for the velocity in terms of a displacement? चला रे स्टूडेंट्स, मला पाहू द्या आणि प्रतीक्षा पवार स्क्रीनशॉट घे. जे विद्यार्थ्याचे आन्सर येतात ना त्यांची स्क्रीनशॉट घे, म्हणजे मला किती विद्यार्थी प्रेझेंट आहेत ते लक्षात येतं. कारण आपल्याकडं 80 विद्यार्थी आहेत. 80 विद्यार्थ्यांपैकी किती विद्यार्थी प्रेझेंट राहतात ते पाहता येतं. कारण ॲब्सेंट विद्यार्थ्यांना कुठल्याही परिस्थितीमध्ये आपल्याला फोर्थ सेमला बसू द्यायचं नाही. त्यामुळं आपल्याला रेकॉर्ड प्रॉम्प्ट ठेवायचं आहे. सो send me the screenshot of the answer. Now you tell me the velocity. Now actually we have to find out the velocity. Then velocity means the rate of a change of a displacement. You know that. We know that. Now I shall write. We know that the rate of change of displacement is the velocity of a particle at that time. So differentiating equation 1 with respect to t. So we can write this as a differentiating with respect to t means which is given by. आता या इक्वेशनचं डिफरन्शिएशन करा. So r bar here I shall write this here. R bar is equals to r bar of q1 comma q2 comma q3 dot 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 qn comma t. Now differentiate. आता याचं डिफरन्शिएशन काय होतं पहा. Therefore dr bar by dt which is equals to, actually here note that r bar is again a function of r bar and which is again the function of q1 q2 q3 dot dot dot. If the dependent variable is only one and independent variables are more than two or more than two, then we have to differentiate that function by using partial method. That means we have to differentiate this with the partial. So we can write dou r bar by dou q1. q1 is the first independent variable into dq1 by dt. This is the derivative of q1 with respect to t. सेकंड टर्म कशी घ्यावं लागेल रे स्टुडंट, सांगा बरं. डो आर बार बाय डो q2 into dq2 divided by dt plus dot 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 plus dou qr divided by dou qn into dqn divided by dt. जेव्हा आर बारचं घेतो तेव्हा पार्शियल डेरिव्हेटिव्ह विथ रिस्पेक्ट टू व्हेरिएबल घ्या आणि पुन्हा त्या पर्टिक्युलर इंडिपेंडंट व्हेरिएबलचा घेतात तेव्हा ऑर्डिनरी डेरिव्हेटिव्ह घ्या. प्लस अगेन वी हॅव टू टेक द डेरिव्हेटिव्ह ऑफ टी, डेरिव्हेटिव्ह ऑफ आर विथ रिस्पेक्ट टू टी. सो वी कॅन राईट dou r bar by dou t into dt by dt but you know that the value of dt by dt is equals to value of dt by dt is equals to 1. So we can write dr bar by dt. It is also called as a velocity. So dr bar by dt, which is given by dou r bar by dou q1 into dq1 divided by dt plus dou r bar by dou q2 into dq2 by dt plus plus dou r bar by dou qn into dqn divided by dt plus the value of dt by dt is again 1. The remaining term is dou r bar by dou t. See this. Now this is also denoted by v bar. Rate of a change of a displacement means velocity, generalized velocity, which is given by v bar, or which is also denoted by dou r bar by dou t, and which is given. Now we can write this summation over summation of first term plus summation of second term, that is summation of q1 plus summation q2, q3, q4. These are the terms which are in addition. So these addition concept, the terms of addition can be written in the form of a summation, that is a summation over j. J is equals to 1 to n dou r bar by dou qj into dqj divided by dt plus dou r bar by dou t. See this is called as the generalized velocity. But generally in this case we have considered the particle from 1 to 3 up to n. So this summation can be shortly written as a v bar is equals to summation over j. There is not necessary to write j is equals to 1 to n because that is a fix. So we can write dou r bar by dou qj. J means 1, 2, 3, 4 into dqj divided by dt plus dou r bar by dou t. See this is called as a generalized expression for the generalized velocity. See this. This is the expression for the generalized velocity. See this. This is the expression for the generalized velocity. This is the expression for the generalized velocity. समजलं का रे? जनरलाइज्ड velocities आपण एक्सप्रेशन कसं मिळवलं तुम्हाला समजलं ना? You know that this is the position vector of a particle or displacement vector. R bar is the position of a particle at any instant of a time t, which is denoted by using the n coordinates, q1, q2, q3, n coordinates, and there is one another parameter, that is a t. T is one parameter. T is a parameter which gives the time at that particular instant. So by using this displacement vector we can obtain the velocity, because the basic concept of a velocity is the rate of a change of a displacement. So rate of change of displacement means actually we have to take the derivative in terms of a time. So we are differentiating this given equation 1 with respect to t, then we get this relation. But r bar is a dependent, position r bar is dependent on different coordinates, q1, q2, q3, there are n coordinates. Means in this case this equation 1 represent one dependent variable and n independent variables. अगर इंडिपेंडेंट वेरिएबल की संख्या 2 से ज्यादा होती है तो हमें क्या करना पड़ता है? You have to take the derivative in the form of a partial. So we have to take the partial derivative and thus we get the result. Next, see this D'Alembert's principle. Actually we know that, काय रे definition, you know that the force, applied force or force, is defined as the product of mass into acceleration. You know that the force of the system is the product of mass into acceleration. Actually we know that. We shall start with this. We know that the force is product of mass and acceleration. That can be written as, therefore we can write capital F bar is equals to m into a bar. But if the force on the ith particle is Fi bar, if the force on ith particle is denoted by, because system is of n number of particles, so we have considered supposed to be ith particle, denoted by Fi bar, whose mass is mi. Mass of the ith particle is denoted by mi, and acceleration is ai bar. So we can write Fi bar means force acting on the ith particle, which is given by mass of the ith particle into acceleration of that particle. But you know that acceleration, what is the formula for the acceleration? Student, now you tell me. Acceleration means rate of a change of a velocity. So we can write mi into dvi by dt. We can write, since a bar is equals to dvi by dt, means v bar is the velocity of the ith particle, so its acceleration of the ith particle is given by dv bar by dt, where vi bar is the velocity of ith particle. I'm going to explain the principle of D'Alembert's principle here. Now this can be written as Fi bar, which is equals to, keep this derivative. Now take this mi bar in the derivative, sorry, mi. M is the mass of ith particle, which is a constant quantity. So it can be taken in the derivative, or we can take out of the derivative. We can take in the derivative mi into dv bar dvi by dt. Okay, sorry, we have taken this derivative outside. So mi into vi bar. Okay, now you tell me what is the formula for mass into velocity. भाग्यश्री देवके, पल्लवी खराडे, मला हे पाहिजे पहा. प्राजक्ता शिंदे आहे का पाहिजे मला. शिंदे तू आन्सर देणं गरजेचं आहे, कारण तू प्रेझेंट टाकून जाते म्हणून मला समजलेलं आहे. प्राजक्ता शिंदे, To answer there, what is the formula for mass into velocity? You know that mass into velocity means what? सर्व स्टुडंटनी सांगा. I shall discuss this. So we can write Fi bar, which is equals to d by dt of mi into vi. Mass into velocity means the linear momentum. Suppose a particle is moving with velocity. Suppose this is a rigid body, or we can consider the system of n particles which is moving with the velocity v bar. Mass of that rigid body is m. So the linear momentum which is the product of mass into velocity. So here mi is the mass of ith particle, vi is the velocity of ith particle, then its product, that is mi into vi, which is equals to the linear momentum and which is denoted by suppose p bar. सांगा रे आन्सर. लिनियर मोमेंटम मास इंटू वेलोसिटीचा काय फॉर्म्युला आहे सांगितलं का कुणी? प्राजक्ता शिंदे आहे का? प्राजक्ता शिंदे आहे. ठीक आहे, प्राजक्ता शिंदे आहे. ओके. So we can write Fi bar, which is equals to d by dt of p bar. See this, we can write mi into v bar, which is equals to pi bar. So we can write this as a pi bar, means linear momentum. So I can write this. Linear momentum of ith particle. So we can write Fi bar, which is equals to dpi bar by dt, which is also denoted Fi bar, which is equals to pi bar dot, means linear momentum of ith particle. Dot means the derivative of dp bar by dt, which can be also denoted by pi bar dot. See this. So this is called as Fi is equals to pi, but we know that Fi bar is equals to pi bar. See this. Okay, so we get the relation this. 1 minute. Now by the virtual work done, now by the virtual work done, or from equation 1 here, what is the formula for the virtual work done? Summation of capital Fi into delta Ri bar. We can take this. So we can write this sides. Now taking this. Now multiplying by delta Ri bar on both sides. We can write this. Now multiplying by delta Ri bar, I am taking multiplying by delta Ri bar and taking summation. So we get summation of, suppose this is a equation number, we can consider this equation number. Okay, this is equation number 1. We can write. Okay, So this is equation number 2. So summation of Fi from I is equals to 1 to n into delta Ri bar, which is equals to summation I is equals to 1 to n Pi bar dot delta Ri bar. So we get the multiplying on both sides by delta Ri and taking the summation. So transfer this on left side. So this can be written as a summation I is equals to 1 to n. See this. Transfer this term on left side. So summation I is equals to 1 to n Fi bar into delta Ri bar minus summation I is equals to 1 to n Pi bar dot delta Ri bar, which is equals to 0. We can take the summation common. Summation I is equals to 1 to n. Summation common kada, delta Ri common kada, then we get Fi bar minus Pi bar dot into delta Ri bar, which is equals to 0. But we know that, see this is called, so we can write this summation over I Fi minus Pi bar dot linear rate of change of linear momentum. PR bar dot means rate of change of momentum into delta Ri bar, which is equals to 0. This is called D'Alembert's principle. This is called the D'Alembert's principle. This is called the D'Alembert's principle. Full stop there. The D'Alembert's principle is also known as Lagrange's Alembert's principle. Lagrange's Alembert principle. See this is a law. What is the law? Summation over force minus rate of change of a linear momentum. Pi means linear momentum. See this. Pi means linear momentum. And Pi bar dot means rate of a change of a linear momentum into delta Ri bar, which is equals to 0. So we get this relation. This is very important relation. Summation over I of Fi bar means force sum minus rate of a change of a linear momentum of the ith particle into the displacement of that particle, which gives a result as a 0. Result as a 0. Here लक्षात ठेवा, this is called as a D'Alembert principle. So how to define the D'Alembert's principle? The displacement of the system of where the applied force is as effective. So we can write this as, याला आपल्याला D'Alembert's principle म्हणतात. हा म्हणा किंवा हा म्हणा, काही अडचण नाही, दोन्ही D'Alembert's principle आहेत. हे प्रूफ लक्षात आलं का रे? कसं आलं ते स्टुडंट्स? प्राजक्ता शिंदे काय म्हणते? प्राजक्ता शिंदे व्हिडिओची क्वालिटी चालत नाही का रे? स्क्रीन क्लिअर होत नाही. ओके, आय शॅल सी दिस. हा दिसतं का? थोडं तुमच्याकडं चेक करा रे. तुमच्याकडं जर नेटची स्पीड जर कमी असेल तुमच्याकडं तर स्क्रीन व्यवस्थित दिसत नाही. लक्षात घ्या, तुमच्याकडं नेटची स्पीड जर कमी असेल तर स्क्रीन दिसत नाही. माझ्याकडनं नेटची स्पीड चांगली आहे, काय अडचण नाही. स्टेट अँड प्रूव्ह द डी अलेम्बर्ट प्रिन्सिपल म्हटलं की यू हॅव टू राईट धिस प्रूफ. यू हॅव टू राईट धिस प्रूफ. हे प्रूफ समजलं का पहा सर्वांना? दिस इज द प्रूफ ऑफ डी अलेम्बर्ट्स प्रिन्सिपल. समेशन ओव्हर आय of Fi minus Pi bar dot into delta Ri by is equals to 0, or we can write Fi bar dot which is equals to Pi bar dot. This is called as a principle of D'Alembert's principle. So I shall write the statement of the D'Alembert's principle. आता याच्यावरून आपण स्टेटमेंट करू. So the statement of D'Alembert's principle D'Alembert's principle. Statement of the D'Alembert's principle. For any displacement of a particle, for any displacement of a particle of a system where the applied force Fi bar is same as the effective force Pi bar dot. Effective force means rate of change of linear momentum. Exerted force means the rate of change of linear momentum. See this. So therefore we can write Fi bar is equals to Pi bar dot. This is the statement of D'Alembert's principle. See this. Or this can be written as, this also can be written as Fi bar minus Pi bar which is equals to 0. And for the system we can write summation I is equals to 1 to n Fi bar minus Pi bar into delta Ri bar which is equals to 0. This is called the D'Alembert's principle. Question कसा आहे तो पहा. Question, see this question. State and prove the D'Alembert's principle. State and prove the D'Alembert's principle. So you have to write the statement. For any displacement of a particle of a system where applied force Fi bar is same as or is equal to the effective force. Effective force means the rate of change of a linear momentum. So this is called principle of D'Alembert's principle, or it is also known as Lagrange's Alembert's principle. हे महत्वाचं आहे रे. समजलं का तुम्हाला? क्रांती सूर्यवंशी, गजानन हिंगमिरे, वर्षा ठाकूर, नवीद खान, सुजाता. हे D'Alembert's प्रिन्सिपल कसं प्रूव्ह केलं? सिंपल आहे, काहीच अवघड नाही. F इज इक्वल्स टू ma पासून सुरू करा, त्यानंतर ith पार्टिकल वर घ्या, त्यानंतर ऍक्सेलरेशनला डेरिव्हेटिव्ह मध्ये लिहा, डेरिव्हेटिव्हला पुन्हा मास इंटू व्हेलॉसिटी मध्ये लिहा. मास इंटू व्हेलॉसिटी म्हणजे लिनियर मोमेंटम असतो. Pi बार लिहा. Pi बारचा डेरिव्हेटिव्ह म्हणजेच Pi बार डॉट. means we get the result Fi bar is equals to Pi bar dot. This is the simple relation, and by using this simple relation we can define the D'Alembert's principle. or we can write आता हे फक्त ith particle साठी D'Alembert's principle झाला. This is the satisfaction of the D'Alembert's principle on the ith particle. So we have to take the system of a particle, then we can multiply by both side on delta I. Delta I Ri bar na multiply kara. So and taking a summation, then we get this result, and this result is called as the D'Alembert's principle. See this. This is a very important result. You must know, or you have to understand this. Okay. काय अडचण आहे का पा? नाहीतर इथं आपण थांबू. काय अडचण नसेल तर थांबू. काय अडचण आहे का विचारारे स्टुडंट्स? प्रतीक्षा, सूर्यवंशी क्रांती काय अडचण